In this video, we will find square root of a number. The video will have three parts. Part A would teach us how we would find square root of a number if the number is a perfect square. Part 2 would teach us how we would find square roots of numbers having prime numbers from 1 to 11 in them. In the third part, we will learn how to find square roots of numbers having prime factors more than 11. Let's start with the part 1 and take an example of 256. We will use factorization method to find the under root of 256. We found out the factors of 256 and we have written them in groups of 2 on the right hand side. We can further write these as squares of those factors. Now we will remove the squares and we will focus on the factors. The result of multiplying these factors is 16. So the square root of 256 is 16. Now we will find out the under root of a number in which its factors are not in groups of 2. We used 768 for an example and we found out its factors and then wrote them in groups of 2 on the right hand side. Each group has 2 numbers but the last one does not have any one to pair with. So now we will represent them as the square of the numbers. Now we have represented these numbers in powers of 2. The last one had no one to pair with, so we took the under root of the number and squared it. So that results into the number itself. So now we will ignore the powers of 2. And now we will multiply these numbers. And now we may remember under roots of some prime numbers from 1 to 11 because they are frequently used. Below is the table that would help us to remember the under roots of prime numbers from 1 to 11. Now we will substitute under root of 3 to 1.732. And this gives us the answer to under root of 768, which is 27.712. And now we will learn about the third category in which the non-grouped factors are greater than 11. We will use 23 as our example, which is a prime number itself. To solve it, we will add zeros. We will add a decimal and then write zeros in groups of 2. We will write the greatest number whose square is less than 23, which is 4. 4 multiplied by 4 is 16 and the remainder is 7. Now we will add the most recent quotient to the divisor. Now we will write a dash next to the divisor. Now we will take down the pair of zeros to make the new dividend and add a decimal. Now we will find a number to write at the dashed place. Number when multiplied by the divisor must be less than the dividend. Using the trial and error method, we found out that 87 multiplied by 7 is just less than 700. So we wrote 7 at the dash and the same number at the top. Subtracting 609 from 700 gives us 91. Now we will add the most recent quotient to the divisor and we will add dash to it. Now we will bring down another pair of zeros. Now we will have to find a number that will go in the dash place. The number should be that when it is multiplied by the new divisor, it must be less than 9100. By using the trial and error method, we found out that the digit should be 9. So we write 9 in the dash and 9 in the top. We can do this method again and again till infinity to get as much precision as we want. The fairly precise under root to 23 is 4.79.